we're on the linear one. So go to the linear section, which is your last section of that packet. So go to the linear section of that packet. Make sure to put your phones away. This is short. Remember, this is nothing new. It's all review. So we're going to the linear function. I know it's linear because look at the graph. What shape is it in? It's a straight what? Line, linear line. And so to find my slope, remember we just count what over what? Rise over run. So over here, maybe to remind yourself, if you couldn't answer this, it's rise over run. I'm going to calculate this one more time. So remember that you take 2 points, doesn't matter where they are, and you count rise over run. And I start left to right. So how many would I go up from here to here? Up 2 over 1. So my slope would be 2. It says to put it in yellow. So up 2 over 1. And I would be able to keep going because they're all up 2 over 1. Who was able to get that? Raise your hand.
Me.
Awesome. So we're on linear. You can either grab it or you can put it in the y-intercept in red. So who can raise their hand and tell me the y-intercept, Amari? 8. How do you know that? Crosses the what? What's that called? It crosses your y-axis, right? So where it crosses your y-axis is your y-intercept. So 0, oh, y, can I never remember? Y-intercept. 0, 8 is your y-intercept. Zeros are your x-intercept. What is your x-intercept here? Negative 4, 0. There's only 1 0 there. You should be writing this in. This should all be reviewed.
I can't even see it.
Now let's write this in slope-intercept form. Y equals, what's your m? 2, x, and what's your y-intercept? 8 plus 8. Beautiful. So there shouldn't be any talking about it tomorrow. Now, standard form, we're not going to have to put it in standard form, but remember it's just ax. We're just going to put the standard form equation. Ax plus by equals c. That's standard form. What's parallel line? For a brain buck, who can raise their hand and tell me how would I know if a line is parallel? I know what you're trying to say, but it's 2 lines, but what about them? They're not touching.
Exactly.
They don't cross. What's the same about them, though? Does anyone remember? They have the same something.
Asymptote. Slope.
They do have the same domain, but they also have the same. They have the same slope.
Exactly.
Do they have the same y-intercept though?
No.
So right here, just write same slope, different y-intercept. So let's think of an equation that could be parallel to this. Y equals, what's the same about it? What number? The slope, the 2. And then what should our y-intercept be? Sure, negative 8. Could it be 1,000?
Yes.
Could it be 10? Could it be 0? Yep, it could be anything besides 8. Positive. Is this function increasing or decreasing? Increasing. Put that on there somewhere. This function is increasing. Amari, what's the domain of this function? What's the domain? Sure. Dante, the domain.
Let's go, Dante.
What's the domain?
I got it.
Beautiful. Negative infinity to
Let's go,
positive
Dante.
infinity. Write this down somewhere. So that means it's going left forever, right forever. Zaylin, what's the range?
To the linear one?
To the linear one, yeah.
Negative infinity, positive.
Beautiful. Negative infinity to positive infinity. It's going up and down forever.
Yes.
For a brain bug, who can raise their hand and tell me, what do we call this? Negative infinity to positive infinity. Don't shout it out. Yeah. What'd you say? All real numbers. So if they say all real numbers, that means negative infinity to positive. Beautiful. Cool. Next one is exponential. They even give you the equation. Kiki, what's the y-intercept? 0, 2. Beautiful. I also can tell because it's my A right there. Dante. Fernando, did you find the growth factor here? You can look at the equation. What's the growth factor? Dante. Looking at the equation, what's the growth factor? I'm asking Fernando. What number? Not 2. That was our y-intercept. What's the other number there? In parentheses. 3. So our growth factor is the number in parentheses. 3. We can also see, so Kiki saw, okay, it starts at 2, and the next point is 6. What do I need to multiply to 2 to get 6? 3. So your growth factor is 3. The asymptote, remember, is the rear end, the end where it's gearing off towards. It's when x equals 0. Jorge, what's the domain? Beautiful. Negative infinity to positive infinity. Damon, what's the range?
Oh, which one?
The exponential equation.
0 to
Beautiful.
infinity.
0 to infinity. Does everyone get how he got that?
Yeah.
Because he looks at the asymptote and he goes, hey, it doesn't go below 0, but it's all the way up to infinity. So it's from 0 because it's your y value. 0 to infinity. Bottom up. Dante, is this function increasing or decreasing? Just looking at the graph. Is it increasing?
Increasing.
I'm guessing probably increasing. Louise, why would it be increasing? But what if I read it like this? How do you have to read it? I heard someone say it. Who said it? It is higher than 1. Left to right, I heard someone say. Increasing when we read it left to right. So when I read it, I can see it's going up. Cool. What type of rate of change does this one have? There's 2 choices, constant or variable.
Oh, it's constant.
Variable rate of change. So variable just means it depends. Like if I found the rate of change here, that's like 0, right? But if I found the rate of change between this, that would be 3. They change. Variable means it changes. Going back to linear, what type of rate of change is this one then?
Constant.
Good. This one's constant rate. So write that down. I forgot with linear. Yeah. So no matter what interval I ask you to find, it's always going to be 2.
Oh.
All right. Last one is quadratic. We haven't really looked at this in a while.
Let me do it.
Which part do you want to do? You do one of them. Which one do you?
Let me see. Let me do the zeros.
Sure. What does zeros mean? X intersect. So what are the zeros, Salem?
5 and 5, 0 and negative 1, 0.
Beautiful.
I want to do the range.
Not yet. So my zeros are 5, 0, negative 1, 0. Do we remember that opposite day? Remember that? So when we write our factors, remember it's the opposite. So what's the opposite of 5?
0. Wait, no.
What's the opposite of positive 5? So remember it's x minus 5. And what's the opposite of negative 1?
Positive 1.
Yep. And so that's factor form. So remember those opposites? So the x-intercepts are opposite of the factors. Who wants to give me another one?
Me.
Sure, Kiki, go for it.
Dang it.
Range, what's her range? Ooh, did everyone hear her? -9 to infinity, because we could see right there.
Girl, watch.
-9, would it be a bracket or parentheses? Bracket, because it's touching -9, right? So -9 all the way up. So remember, range is bottom up. Beautiful. Who wants to give me another one? Isabel, go for it. Beautiful. How'd you get that? Good. You look at your vertex and it's, remember, symmetrical. It breaks it in half. This line is what x equals 2. Beautiful. Who wants to give me another one? We just got that one. X equals 2. It's in yellow. Give me another one. Sure. What's the domain? Yep. Negative infinity, positive infinity. Go in both directions forever. Kamaya, what's the vertex? 2. And what's the y coordinate? -9. Perfect. And we can see that's where Kiki got her -9 from.
Hey, Kiki.
Now, this is the part that we might not remember, increasing and decreasing. So write that somewhere on your paper. You could write it underneath the graph. Increasing, and this is what you guys had a lot of trouble on during this unit. Increasing and decreasing. So remember, Louise said, or somebody said, read it left to right, right? So when I'm reading it left to right, what's happening with this parabola? It's going down until we get to where x is what? That's your y. What's your x?
2.
2, right? -9 is your y. X is 2. So when x is less than 2, I know the function's decreasing. Remember this? A lot of us struggle with that. So when x is less than 2, I just drag my finger and I go, okay, it's decreasing up until my x is 2. Then, once I get to 2, what's happening? It's increasing. It's going up. So when x is greater than 2. That's increasing and decreasing. Does this have a variable rate of change or a constant rate of change? Variable. The only one that's constant is linear. So, that was your lesson, right? So what you guys are doing is you're looking at the worksheet, and it looks something like this. It gives you 3 graphs. This is what it's going to look like on your milestone. This is what it would look like. It would give you 3 things like this, and they want you to compare them. So first they want you to tell them what type of function it is, the domain and range. Asymptote, there's only one. Which is the only equation that has an asymptote? Exponential, right? So if it doesn't have it, just draw a line through it. Increasing, decreasing, don't worry about end behavior for right now. Y-intercepts, they want the rate of change over 0 and 2. And then the last 2 things, they want what's one similarity and one difference. Does that make sense?
Nope.
What doesn't
Not
make
at
sense
all.
about it?
Everything makes sense.
This, just skip it for right now. Just skip the end behavior. We'll go over end behavior at the end of the class. But do you get everything else, what you have to do? So like you're going through and you're going, okay, let me do f of x first. Which color is f of x? Which one is f of x? This line, right? What type of function is that? Yep, so I would come over here and I write linear. What's always the domain of linear functions? I'll help you. What's the range of linear functions? Yep. Does a linear equation have an asymptote? No. Is this function, is it increasing or decreasing? Decreasing, right? So it is not increasing, it's decreasing. You can skip end behavior for right now. What's the y-intercept of that one? 3. Rate of change, it has a constant or a variable rate of change? Constant, right? So what's the slope? It's in the equation. Negative 1/2 right here, right? So I know no matter what, my slope's going to be negative 1/2. And then at the end, you would find similarity and difference. That's it. That's all you're doing for each one. You want me to go through one more with you, and then the back you guys can do on your own.
Ouch.
You are handing this in today, so I want to make sure you guys know what you're
I'll be handing you a note.
doing. This isn't notes. The notes are the pink. All right, let's try the next one.
I smacked myself.
Let's look at g of x. What type of function is g of x? They're talking about this blue thing right here. What's that called? Quadratic. What shape is that in? A parabola. So that one's quadratic. What's the domain of that quadratic function? I would write this down because if you're not writing it down, this is getting graded. So like I'm giving you the answers to this one. So if you're not writing it down, you have to do it on your own. Now looking at this, what's the range? Negative 5 is the lowest to what? Infinity. Good. So it'd be negative 5 to infinity. Does a quadratic function have an asymptote? No. Now, looking at it, we need to figure out when it's increasing or decreasing. So we're looking at the axis of symmetry, which is 2, right? When x is less than 2, is it increasing or decreasing? Like from here to here? Decreasing. So when I go over here, when x is less than 2, it's decreasing. So when x is less than 2, it's decreasing. When x is greater than 2, it's increasing. What is the y-intercept of that function? Good. 0, -1. Now the rate of change is going to be different. 0 to 2, I would have to go to 0, which is right here, and then to 2 right here. And I'm just going to count rise over run. If it's from here to here, is it going down or up? Like from left to right? Down. So I know it's going to be a negative slope. How far is it going down? 1, 2, 3, 4. And then you're going over 2, so it would be -2. So my rate of change would be -2. I'm just going to go through the whole thing, and you're going to be doing the back. But we are still grading the front. So if you're not writing it down, I'm going through it. Is that just a check?
Okay, so where's my stuff?
What? That's a check. Yeah, the only reason I had to do it for quadratic is because it is increasing and decreasing. It's decreasing up to here, then it starts increasing. So the next one will be. So last one, the h of x one, the green one. What's that kind of? What is that? Exponential. What is the domain of that one? Negative infinity. Good. Negative infinity to positive. Good, let's look. So good. So it's -3, and what's that called? Asymptote. So I could also fill in that. I know my asymptote is where x equals -3. And so my range is -3 to infinity. No. Is that function increasing or decreasing? Increasing because it's going up, right? So check off increasing. Stop, gentlemen. What's the y-intercept of that? -2. Then the rate of change over 0 and 2. So I start right here, 0, and here's where it falls at 2. So I got to count rise over run. How much does it rise? 1, 2, 3, and over how many? 2, right? So So your rate of change would be 3/2.
Oh, that you?
What similarity do they all three have? Same domain.
I was going, hey.
And what's a difference? There's a million differences, but name one.
Yeah,
They all have different ranges. What else? Different y-intercepts. Only one has an asymptote. So you can write whatever you want. I'm going to write different y-intercepts. They all have different y-intercepts.
That's not a bracket right there.
They all have different rate of change. What?
That's not a bracket.
This one? No, because remember the asymptote, they never actually. But the quadratic it does because it oh, yeah. So, what you're doing now is you guys are going to have 15 minutes to do the other side. It's the exact same thing, but different graphs. So you're going to have 15 minutes to do this one on your own. Yeah, it's the same thing, but now you're looking at the 3 different ones. So we're going to put a timer on for 15 minutes. And so after that, we'll explain what we're doing, but we want to make sure, does anyone have any questions on any of these?